Hi friends, this is Gautam. In this video tutorial, I am going to discuss about three-way handshake and four-way handshake of TCP protocol. So three-way handshake means how the TCP will create the session, and four-way handshake means how the TCP will terminate the session. So I will show it to you in real time. So this is my example scenario. So before watching this video, just go through OSA layer plus basic TCP concept and TCP header video. So these all the concepts I already uploaded in my YouTube channel. Please go through it, then you can watch this video so you can able to understand what I am saying. Okay, so this is my example scenario. I'm using two router R1, R2. So in point-to-point network, I'm using 200, 200, 200, 0/30. So here I will assign 1, here I will assign 2 IP address. Okay, so now I just capture Wireshark between this point-to-point network. So in R2 router, I already configured Telnet. So Telnet comes under TCP. So from R1, I am trying to Telnet R2. So before doing that one, I will just capture the Wireshark start capture. So if you want to know about more about Telnet concept means just go through my channel. I already put separate video for Telnet concept. So Telnet is used to access the remote access to that device. Okay. So now the Wireshark is running. So just go to R1 router. So in R1 router, I will give Telnet. Then I will give R2 router IP. So R2 router IP is 200.200.200.2. Enter. So username is Cisco and password also Cisco. Enter. So enable password also Cisco. Okay, now I will access into the R2 router. So just exit and terminate this session. Okay, so now I just stop capturing this Wireshark. Okay, so now we can check the Wireshark file. Okay. Okay, so this is in simulation. They are using CDP protocol by default, so just leave it this packet. So here we can see this is the first packet, three-way handshake. So here we can see, so 200 200 201, this is a source IP. 200 200 202 is a destination IP. So protocol is a TCP. Here we can see 51421 is a source port number. So in OSI layer itself, I told you in layer 4, so we are using 0 to 65535 port number. So 0 to 1023 is a well-known port number. 1024 to 49151 register port number. 49152 to 65535 is a dynamic port number. So here we can see 51421 is a dynamic port number. So here 23 is a well-known port number. So this 23 indicates the Telnet protocol. So first R1 will send the synchronized packet. So here we can see sequence number is 0. So this window size and length MSS. So I will put separate video. I will teach you more about this one. So in TCP we can use window scaling. So I will put separate video for that one. Okay, so R1 send the synchronized packet to the R2. So R2 will reply back to that packet acknowledging. So that's why here we can see acknowledge plus synchronize. So now R2 send the synchronized packet to the R1. So this signature is a flag. These both of them are flag. So here R2 also use the sequence number 0, and here they are using acknowledgement 1. Acknowledgement 1 means I will receive your packet. So that's why they are sending acknowledgement 1, because here sequence number is 0. Here they are sending acknowledgement 1. So again R1 acknowledging for this packet. So R2 send the packet to R1 using sequence number 0. So that's why R1 router again send the packet to R2. Here sequence number 0, here sequence number 1. Here they send the acknowledgement 1 for this packet. So here the three-way handshake is completed. Now the session will be started. So here we can see telnet. So this all of the things are packets data. So for an example, if I'm right clicking and give follow TCP stream, so here we can see exact output we can capture in Wireshark. So C, so each and every packet C, one packet I, one packet S. So likewise the username and password, everything is sending to the R2 router. And here see first packet three-way handshake. Okay, so here the sequence number is 0. So here in bracket they mention relative sequence number. So in TCP header itself I told you the sequence number is randomly generated number is based upon the operating system. So here they mention sequence number is 0 because this is in simulation. So that's why in Wireshark they will show it as a sequence number 0. So for an example, if I'm right click, so in protocol preference I will just untick the relative sequence number. So now we can see the sequence number is random sequence number is a 32-bit field. So here we can see 130814161. So if I'm right click and give protocol reference, I'll give the relative sequence number tick. Now we can see sequence number is 0. So this is for simulation. So that's why in Wireshark they will enable the relative sequence number. So relative sequence number means it will start with 0. So for three-way handshake, but in real time it won't like that because the sequence number is random generating number. So here you can see random generating number is a 32-bit field. So it's a very big number. So if it's sequence number means it's very easy to read and understanding for studying purpose. Okay, so after three-way handshake the R1 and R2 will sending the data. So telnet data, each and telnet data, each and every packet they will sending each and every character. So and one more thing, in previous session in TCP header I will told you the push flag. So for an example, if I'm taking telnet data one packet, so in flags here we can see push flag. So push flag means in already we'll discuss about that one. So R1 router sending to R2 during the three-way and after three-way handshake it will send the data. So before that the data will be sent it to the R1 receiver, R1 buffer. From that R1 buffer it will send to the R2 router buffer. From that R2 router buffer it will move to the OSI layer, application layer. But in case if it's telnet or SSH means the data R1 router won't send the data to the buffer. It will be directly sending to the R2 router, and R2 router also receiving the data directly. It won't receive the buffer. From the buffer it won't take it. So it will receive directly and move towards the application layer, because each and every if you are pressing C means it automatically the data will be sent. So it won't send to the buffer. If some other application means the data will be first the sender will send to the buffer. From that buffer it will send to the R2 receive the data to the buffer. From that buffer it will move to the application layer. But in telnet it will be sending immediately. So that's why we are using push flag. So here we can see flag push. Okay, so now the data everything will be sended. So after sending the data, here we can see four-way handshake. So four-way handshake means it will be terminating the session. So for terminating the session it will send the first R2 router, because in R1 router I will give telnet and I will give the R2 router IP. So it will ask username. So R1 initiate this session. So that's why three-way handshake we saw here, the three-way handshake. Then afterwards username, password and enable password, everything is this data, telnet data. So after that in R1 router, so I am accessing the, so here we can see the telnet data. So from here you can take it, this packet. Okay, so here we can see first packet C. So it won't wait for until you have to give full username and password. If you are giving single character C, it will send the data immediately. Here we can see telnet data C. So next one, so that C I received, so that's why they're getting the acknowledgement also. Next one, C I, then this packet also I think. CIS. So each and every character they're sending. So that's why each and every telnet data it will be showing here. Okay, so after from R1 router, I'm using Telnet. So the three-way handshake will be established. Then afterwards only the data will be sending because TCP is a reliable protocol. Okay, after logging to the R2 router, I will exit from the R2 router. So that time the TCP session will be terminated. So that should be in four-way handshake. So here we can see 200, 200, 202. So because I'm logging to the R2 router, from the R2 router only I will give exit. It will be exit from the TCP session, exit from the Telnet. So R2 router sending the fin means finish bit. This flag is fin means finish bit, and TCP and telnet they will use push flag. So that's why here push flag and acknowledgement. So this acknowledgement indicates R2 router sending fin bit to the R1 router. I am going to terminate this session. So the fin flag should be there, and acknowledgement means whatever you are sender, I will receive everything. For the final acknowledgement, they are sending this acknowledgement packet. Then R1 router acknowledge to that fin bit. The finish bit sent by the R2 router that will be acknowledged by the R1 router. That's why they are sending here acknowledge. Then here we can see sequence number 132. For this segment they will acknowledge 133. Then now R2 router, then R1 router sending the fin bit to the R1 router. R1 router sending the finish bit to the R2 router. So here we can see fin flag, then push and acknowledge. So now R1 also saying I will receive everything from you. So they are also sending final acknowledgement in that packet itself, in the segment itself. Then afterwards R2 router acknowledge for that fin. So the finally the TCP session will be terminated. So this is the four-way handshake. Here we can see R1 router sending R2 router, sequence number is 57. Here R2 router 200, 202, 200, 200, 201 sending acknowledgement. The acknowledgement number is 158. Here 57, here 58. And also in Wireshark, here we can see, so here in left side the line will be started. Here the TCP session will be started. So left side here we can line. Here the TCP session will be started. Then after fin flag it will be terminated here. So three-way handshake is used to create the session and sending the data. After sending the data it will be terminating the session using four-way handshake. So the finish bit is sent by the both device. They will acknowledge. Then only the TCP session will be terminated. Okay friends, I hope you can understand this concept. If you have any queries, please ping me. I will reply to your query. So in this video tutorial, in the description itself, I will attach the link. Just click that link and you can download this Wireshark file. So just go through that file. If you have any queries, please ask me. I will tell you. And also before opening that file, you should be install Wireshark in your laptop. Then only you can able to open that file. So in next video session I will explain you the TCP states. So I hope you understand this concept. Thank you friends. Thank you for watching my videos. Subscribe my channel for further updates. Thank you.